In section 2, we're going to continue our conic section discussion with circles and ellipses. We're going to start with circles. And we actually already know a lot about them. I think we've already completed the square with circles. And so if you have a circle, its standard form is x minus h squared plus y minus k squared equals r squared. And from this form, its center is h comma k and its radius is r. We've already dealt with these. Circles are actually the easiest conic section. They have the least amount going on because they have the same radius in all directions. All points are equidistant from the center. You don't need to worry about foci, any of those other things, because everything has one point that is equidistant between instead of multiple points or bars. Okay, so we'll do one example with the circle and we'll move on to the ellipses. So let's say I have the equation x squared plus y squared minus 16x plus 14y plus 32 equals 0. I want to find out what this circle looks like by finding its center and its radius. So the first thing to do, completing the square, is going to move the x's together. So I'm going to have x squared minus 16x, leave a space, plus y squared plus 14y, leave a space, equals, and subtract the 32 to the other side. We're going to use that space to complete the square. So we're going to have, say, n equals half of b, so negative 16 over 2, so that's negative 8. And then n squared is 64. So I'm going to add 64 into this space on both sides. Add 64 to both sides. We've got n, so we're going to find m, some other letter, for the y's. So it's our 14 divided by 2, so that's 7. And then m squared is 49, so we're going to add 49 to both sides. All right. Now, these are both factorable, so it's going to factor into x minus 8 squared. Negative 8 times negative 8 is 64. Negative 8 plus negative 8 is 16. It always factors into x minus n squared. Plus y plus 7 squared. Again, y plus m. 7 times 7 is 49. 7 plus 7 is 14. Equals, and then negative 32 plus 64 plus 49 is 81. Okay, so this circle has a center of actually hk, and so remember that we have opposites here, so it's x minus h, so that means that h is 8, y minus k, so k is negative 7, and then 81 is our r squared, so that means that r is going to be 9. So we know that we have a center of 8 comma negative 7 and a radius of 9, and that's the circle. All right. So next, let's talk about the ellipse. The ellipse is going to have some more interesting features. Okay, so there are two kinds of ellipse. There are ellipses that have a longer horizontal axis, and there are ellipses that have a longer vertical axis. Okay, so we'll talk about both cases. So if I start writing what the equation for the ellipse would be, it's going to be x, it looks like a circle, so it's x minus h squared, but it's divided by a squared, plus y minus k squared, but it's divided by b squared, and then it's equal to 1. Okay, now depending on whether a is larger or b is larger, I get the horizontal versus the vertical orientation. So if the denominator of the x value is larger, then I get the horizontal. So this is the case for if a is larger than b. If b is the bigger one, then it's going to be a vertical orientation. Okay, so the ellipses, I'm going to have to divide and talk about both of these separately in terms of other features of them. We talk about the points on the long edge of the ellipse as the vertices. So there are two vertices here on the edge. So I'm just going to label that V for vertex, vertice. So one of the vertices and then the other of the vertices. And let me throw in our center point. So our center point is HK. Okay, so that comes right from the same where the circle centers come from, HK. And so we have our vertices. And so the vertices are going to be a distance away that corresponds with whatever A or B is. So we're actually a distance A away and B away from both edges. So this one's again a distance A away and B away. A is the horizontal, B is the vertical, just because I have B under Y, so it's the vertical, and A under X, so it's the vertical. Okay. Now, we don't have names for the minor ones, so we have the major axis and the minor axis. All right, so I'll label these. We have our major axis and our minor axis. In this case, major's just bigger, so this one's the minor axis, and this one's the major axis. And the vertices are always on the major axis. We have the vertices on the major axis. So we don't have, I mean, there are points here, we don't have names for them in the minor axis. So if I wanted to write information down about the vertices, they are A or B units, depending on if we're a horizontal or horizontal major or a vertical major away. And so from the center, they're going to be A units away in both directions. So we're going to have H plus A, comma K, and we're going to have H minus A, comma K. Those are going to be the two vertices, right? You go A away from the center in both directions to get both of those vertices. And so if you are vertical major axis, your major is in the Y direction, so it's going to be H, comma K plus B, and K minus B. Because we're moving in the vertical direction instead of the horizontal direction. So those are your vertices depending on which orientation you have. The length of the minor axis is 2b, the length of the major axis is 2a. So we can talk about the length of the axes. Okay, so the major axis, this is the length, is 2a, and the minor axis is 2b, and then over here again the major axis length is 2b because b is major over here, that's its length, and your minor is 2a because that's your minor if you're vertically oriented. Okay, and the last thing that the ellipse has is it has a focus near somewhere on the major axis. It has a focus, or two focuses. They are symmetric. So it has foci, which is the plural of focus. So it has two foci on the major axis. And the true definition of an ellipse is going to be all points. So basically, okay, if you put two push pins down in the focus and a fixed string length between them, and used the string to wrap around and draw the ellipse, you're tying it between the two foci. So with just the two foci and a fixed length string, push pin the two ends of the string down, put a pencil in your string, you can draw the ellipse. That's how it's really truly defined. So we have our foci over here. So the foci help define what the shape of this ellipse is going to look like, where they're at. All right. And so, how do I find the foci? That's the last piece I need to find. So the foci are each of length c away, where c is defined by major axis squared, so a squared minus b squared, if it was in this orientation. So for the foci, so c squared is equal to a squared minus b squared, or if b is longer, then you would do c squared equals b squared minus a squared. And so the foci are just points, and so you're going to go h plus c, h minus c. So your foci are going to be at h plus c comma k, and h minus c comma k. It's just like the vertices, but we're adding c instead of a. And they're going to be at h comma k plus c and h comma k minus c if your foci are along the vertical axis. Okay, I'm just pausing to make sure you have a chance to write notes down before I switch the screen. So if you want to pause the recording, that's okay. I'm going to flip to the next page. Also, I do have it printed if it's easier to see things printed. That's information about ellipses and circles. So again, I can pause if you want to pause, so you can capture some of what's written down there. It's the same thing that I had written down on paper. It's just typed. There's also information about hyperbola, but we're not going to talk about hyperbola. If you need to look at hyperbola, they are in section 10.2. We're going to stop at the ellipse. Hyperbola aren't used as commonly until you get a little later on. I think you'll probably deal with them and see them a little bit in Calc 3, but that's several semesters away, so we're going to stick with ellipses as our ending point here. Okay. So, resuming, we're going to take a look at an equation that's an ellipse, and we're going to try to identify some of those important features. I think I'll check my time.